Hi everybody, this is our second video covering section 1 of chapter 6. In this one we're going to talk about finding the greatest common factor of a polynomial, and we're going to use that factor to, well, you guessed it, factor the polynomial. Okay, so in this video we're going to talk about how to find the greatest common factor of a polynomial, and we're going to use this to actually, once again, factor the polynomial. So, how do we find the greatest common factor of a polynomial? Well, we take each term in the polynomial and we find its greatest common factor. So, and here we have some pretty quick examples. For the first one, we have the polynomial 6n plus 30. It is a binomial. And the greatest and we can use the tools we learned in our previous section to actually find the greatest common factor, and we will find that the greatest common factor for this would be 6. So for here, the GCF is equal to 6. For part B, the greatest common factor here would be 5x squared. Why is that the case? Well, 5, for as far as the coefficients are concerned, well, 5 is a prime number, and 15 can be factored into 3 times 5, both of which are prime numbers. So we have our prime factorization, and they both have 5 in it, here and here, and that gives me my, there, and that gives me my 5, and then here I have 2 x's, here I have 3, so they both have 2 x's in common, x squared, and there we go. Now notice here we have a 2, we have a 3, and we have a 2. They are prime numbers, so we don't have to do any more prime factorization, but they are different. As a consequence, these do not have any factors in common with the exception of one, the universal factor, which happens to be 1. So the greatest common factor here is 1. And then finally, the greatest common factor for this one would be 2a squared. Whoops, equals 2a squared. The 4a can be factored in, the negative 4a can be factored into a negative 2 times 2a to the 4th plus 2a cubed minus 2 times 3a squared. They all have a 2 in common, and they all have 2 a's in common. So that's it. That is how we find the greatest common factor for our polynomials. Okay, now we're going to use this to actually factor a polynomial. And how do we factor out the greatest common factor for a polynomial? Well, first, we find the greatest common factor. And for this particular polynomial, the greatest common factor happens to be 6x cubed. For the first one, we would have, if we did a prime factorization on 24, we would have, 6 times 4, and then 6 is factored into 2 times 3, and then the 4 is factored into 2 times 2. So that would give us 2 times 2 times 2 times 3. And then we have our x to the 6th. For the 12, we have 3 times 4. And then that can be factored into, the 4 can be factored into 2 times 2. 2 times 2 times 3. And we have x to the 4th. And then for 18, we have 3 times 6. 6 can be factored into 2 times 3, so that would give us 2 times 3 times 3, and then we would have x cubed. Okay, and then notice that they each have 1 2 in common, so it gives me my 2. They each have 1 3 in common, that gives me my 3. And then this has 3 x's, this has 4 x's, and this has 6 x's, so they all have 3 x's in their terms, which gives me my x to the cubed. Doing the multiplication, we have 6x cubed. Now, we can write each term, now we want to write each term as a product of the greatest common factor and some other factor which will produce this term for us. So we can rewrite 24x to the 6th as 6x cubed times 4x cubed. 6 times 4 gives me 24. X cubed times x cubed gives me x to the 6th. Okay, for this one, for 12x, I can rewrite 12x to the 4th as 6x cubed times 2x. 6 times 2 gives me 12. X cubed times x gives me x to the 4th. And then finally, I forgot to do the red part here, we have 18x cubed can be written as 6x cubed times 3. 6 times 3 is 18, and of course x cubed comes up with it. Once we have that, we can now factor out the greatest common factor by kind of using the distributive property in reverse. Notice that this is equal, that now we have 6x cubed times this term minus 6x cubed times this term minus 6x cubed times this. We can factor that out and then enclose the remaining factors in grouping symbols. And that will give us 6x cubed times the quantity 4x cubed minus 2x minus 3. And of course, if we use the distributive property, we would recover the original equation. And this is what we call factoring. It is kind of like the reverse of the distributive property, or doing it backwards. So here are some examples, and these are the exact same examples that we worked before. So for the first one, the greatest common factor happens to be 6. So I can rewrite the first term as a product of the greatest common factor, which is 6, times n. And that gives me 6n. Plus, then for the second term, I can write that as 6, or GCF, times 5, which will produce 30. And now I can move the 6 outside, provide myself some grouping symbols, and put the n plus 5 inside. Notice that n plus 5 cannot be factored. There's nothing in common between those two terms, but 6 times n gives me 6n, and 6 times 5 gives me 30. So this is factored. This would be equal to 6 times the quantity n plus 5. Now for the next problem, the greatest common factor was 5x squared. Okay, well, once again, we can rewrite, we can express 5x cubed as the product of the greatest common factor plus another factor, which in this case would happen to be equal to x. And then for the minus 15, we would have the product of the greatest common factor, which once again is 5x squared, times times some other factor which will produce for us 15, and of course that would be 3. And now we can factor out the 5x squared, and the remaining factor will be the quantity x minus 3. Does that make sense? Well, yeah, 5x squared times x is 5x cubed. 5x squared times 3 is our 15x squared, and of course we have our minus sign. Okay, what about the third one? Well, for the third one, the greatest common factor is equal to 1. Okay, well, if the greatest common factor is equal to 1, that means outside of 1, there are no common factors. As a consequence, this is not factorable. This cannot be factored. Oops. GCF equals 1 cannot be factored. Okay, now for the last one, the greatest common factor is equal to 2a squared. Cool. We want to find here the other factor of negative 4a squared. In other words, that term, which when we multiply it by 2a squared, will give us 4a squared. 2a to the, or will give us 4a to the fourth, not 4a squared. And that would be 2a squared times negative 2a squared. Okay? And then for this one, we want the factor that the factor that we have to multiply by 2a squared to get 2a cubed is just simply a. So this will be 2a squared times a. And then finally, we will have 2a squared, and we would need to multiply that by a negative 3 to get 6a squared. Okay, factoring that out, we would have 2a squared times the quantity negative 2a squared plus a minus 3. Okay, now it turns out that we are not really big fans of having a negative coefficient as our lead term, as our leading coefficient. So the other way to write this would be to, and it's actually the preferred way to write this, would be as negative 2a squared times 2a minus a plus 3. And that brings us to our next particular topic, and that is this. Suppose that you actually have a polynomial where the leading coefficient happens to be negative, then instead of factoring out the greatest common factor, we want to factor out the negative of the greatest common factor. For example, here we have negative 6x cubed minus 6y. The greatest common factor happens to be equal to 6, but we want to factor out a negative 6 instead. So what we're going to do is we're going to take our negative 6 and we're going to find the other factor that we need to produce negative 6x cubed. In this case, it will be x cubed. Okay? And then plus here, we're factoring out a negative 6. And then we want to find the coefficient that will produce for us a negative 6y. And of course, that will be y. Okay, so now we have negative 6 times x cubed, which provides us negative 6x cubed. Here we have negative 6 times y, which provides us with our negative 6y. Now we can factor out the negative 6. Here it is. And here is our x cubed plus y. And is the original polynomial, can the original polynomial be recovered from this? And the answer is yes. Negative 6 times x cubed using the distributive property is negative 6x cubed. Negative 6 times y using the distributive property is negative y. Okay, in our next example, we have a leading coefficient of negative 13, and our polynomial has two variables, negative 13xy cubed minus 39x squared minus 26x. Okay, the greatest common factor here is 13x, but we want to factor out a negative 13x. And if we do, well, first we have to find the other factor that will produce for us negative 13xy cubed, and that of course would be multiplying this by y cubed. To get negative 39x squared, we would need to multiply negative 13x by 3x, and to get negative 26x, we would need to multiply negative 13x times 2, which is how we get this expression here. Now we can take the 13x and we can actually move it outside of a set of grouping symbols, leave the other terms inside, and this is how it will be factored. And notice that negative 13xy cubed produces this. Negative 13x times 3x produces negative 39x squared. And finally, negative 13x times 2 gives us negative 26x. And now it is time to do examples. And here is the first one. Here we have negative 6y minus 3x. The greatest common factor is 3. So we want to work with negative 3. So here we will have negative 3 times 2y to get our negative 6y, plus then our negative 3 again. And we want to multiply that by x squared. Okay, so now we can take the negative 3 out. And then we will have y plus x squared. And there it is factored. Okay, now for the greatest common factor here, we have 13, and we have an x and a y here, so it will be 13xy. Now notice here we do not have any, notice here that our leading coefficient is not negative. This happens to be positive. So we do not need to look at the negative of the greatest common factor. So instead, we just want to figure out what we need to multiply 13xy by to get 13xy squared, and that of course is multiplying it by another y. And then we need to figure out what we need to multiply 13xy by or with to get 26x squared y, and that would be 2x. Then we can use our distributive property in reverse, and we will have 13xy. That's not a 13, that's a 12. 13xy times the quantity y plus 2x. Okay, for this one, the greatest common factor here happens to be equal to 2. Why is that the case? Well, the factors of 22 are 2 and 11. Both of which are prime. The factors of 26 are 2 and 13. The factors of 10 are 2 and 5, since it's 2. And since this has no x, y, or z terms, it's just simply 2. Now, since the leading coefficient is positive, or more likely not negative, we just need to work with our 2. So we are going to have 2 times 11x to produce 22x plus 2 times 13x squared to get our 26x squared plus 2 times 5 to get our 10. We can factor out the 2, and we will have 2 times the quantity 11x plus 13x squared plus 5. And there you go, that's the answer. Now here, the greatest common factor is going to be 3x. Each of these terms has a 3 in common, and this one is a prime number, and each of these terms has 1x. Okay, but notice here that our leading coefficient happens to be negative, so we want to use negative 3x. Okay, so negative 3x times 5 will produce for us 15. Plus negative 3x times 13x will produce for us negative 39x. And then finally, negative 3x times y squared will produce for us negative 3xy squared. Almost forgot that. Now we can factor out the negative 3x, and we're left with the quantity 5 plus 13 plus y squared. And there you go. That's it. Now, we have one more set of problems to look at because these are actually in your homework, and here they are. Here, we have a polynomial, and they were kind enough to give us the greatest common factor. And here we have a polynomial, and they were kind enough to give us the negative of the greatest common factor. So what we want to do is to find the other factors, the other factors that we need so that this polynomial will be recovered. Okay, so we need to find that factor of 3x squared that we need to find the other factor of 9x squared when the first one is 3x squared. And of course that would be 3. Because 3x squared times 3 is 9x squared. And now we need to find the other factor of 3x to the 4th. Okay, well, if 3x squared is one factor, then the other factor will be x squared, because that will provide for us 3x to the 4th. And of course we want to keep a minus sign there. And there we go, that's the first one. Now for this one, we want to find the other factor of negative 5x to the 4th y squared. We already have a negative 5, we already have one x, we already have both y's, so we just need to get 3 more x's. So that would be x cubed. And then finally, we want to find the other factor of 15xy squared. Well, we already have a negative 5 here, so we basically want to multiply that negative 5 by 3 to get negative 15. We have 1x here, 1x there, so there's nothing to do. And we have a y squared here and a y squared. There's nothing to do, so this right here would be your answer. And that is all that I have for the lecture portion of this particular video. Sit tight, and I will get Hawks up and running, and we'll do a couple of problems. Okay, so here we are in Hawks, and let's go and do some practicing. Here is our first problem, and we have 4 plus 22x. And it turns out in this particular case, the greatest common factor is going to be 2. So we can rewrite this as 2 times 2 plus 2 times 11x. Now we can factor out that 1, 2, and that will give us 2 times the quantity 2 plus 11x. And let's see if I'm right. 2 parenthesis 2 plus 11x, the other parentheses there, so I don't need to worry about that. And I hit enter, and wow, I am right. Okay, so let's move on. Okay, let's go ahead and do this one. Here we have 10 xy squared plus x cubed y cubed. So the greatest common factor for these two terms is going to be x y squared. As a consequence, we can rewrite this as x y squared times 10 plus x y squared times x squared y. And then factoring out the xy squared, we're going to have xy squared times the quantity 10 plus x squared y. Does that make sense? Well, multiplying this by 10 gives us the first term. X times x squared gives me x cubed. Y squared times y gives me y cubed. So that should be correct. So x, y, caret, square, arrow, parenthesis, 10 plus x caret squared, arrow, y. There we go. Okay. Okay, here is a 3-term problem. Here we have negative 15y plus 25xy squared plus 35x to the third. Okay, so now hopefully you can see here that the greatest common factor happens to be y. No, not y, it happens to be 5. However, we have a negative leading coefficient here, so we want to work with negative 5. So we want to find all the factors that the factors of the, or the we want to find the other factor which will produce these 3 terms. So we have negative 5, and to get 15y, we would need to multiply that by 3y. And then plus, we're going to have a negative 5. And then to get negative 25xy squared, we would need to multiply that by negative 5xy squared. And then plus, once again, a negative 5. And then we're going to multiply this by negative 7x cubed. And then factoring out the negative 5, we have negative 5 times the quantity 3y minus 5xy squared minus 7x to the cubed. And there you go. And let's do one other problem. How about this one? Okay, this is, here we have 28x cubed minus 4x, and we need to figure out what the other factors are. We know the greatest common factor here is 4x, and we need to figure out what the rest of it is. Now, what do we need to multiply 4x by to get 28x cubed? Well, 4 times 7 would be 28. X times x squared will give me x cubed. Then I have a minus. And then what do I have to multiply 4x by to get 4x? Well, how about 1? And that should be the answer. And there you go. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.